All right, guys, welcome back again. My name is Mutiat Hostman, and we are now in week 3 of day 1. And this week is all about machine learning, yes. And I know a lot of you guys are super excited, and I am too. So, guys, let's get into class. So, today let's talk about machine learning. What do we mean by machine learning? Machine learning is a subset of artificial intelligence that enables the system to learn patterns from data. And the goal of machine learning is to make predictions or decisions without explicit programming. And it helps to improve automatically as it is exposed to more data. Now, let's bring this back a little bit. The first thing you should understand is the performance of any machine learning model or algorithm you see out there is as good as the quality of the data you provided. So, this is to tell us that the data preprocessing part is very, very important because if the quality of your data is not good enough, trust me, the performance of your machine or the performance of your machine learning is going to be worse. If something is bad and then you bring your machine learning, it's going to get worse. So you need to work more on the preprocessing phase. Make sure that your data is properly preprocessed and clean before your machine start learning from that data. The quality is as good as the quality of your data. So let's not forget that data preprocessing is the key for you to optimize the machine learning. All right, so let's talk about this a little bit more. I said the machine learning is a section, is a subset. It means that the broader sense of machine learning is what? Is artificial intelligence. That's the big body. And a section of that is where we get the machine learning. And what's the essence of machine learning? We're trying to build a system that can learn a pattern from a data. It depends on how we want it to learn the pattern. But the cocoa is that the main thing is that the system is learning directly from the data. And what is the goal? We're trying to make predictions. We're trying to build a model that we can understand the relationship between the input and the output that we are getting. So that with that, we can predict for what is to come and how the data and how the model can prepare for data that he has not seen. Okay. And then, of course, with that, it will improve automatically as it is exposed to more data, even data that he has not seen before. Okay. So let's go into the types of machine learning. Now, the types of machine learning, we do have the supervised learning, we have the unsupervised learning, we have the reinforcement learning, we have active learning, we have a lot of machine learning. But for the purpose of this class, we're restricting it to 3 types of machine learning because we do know that at the end of this class, if you understand this clearly, there you can always modify to other types of machine learning. And these are the most common types of machine learning. Okay, so what is supervised learning? Now you need to understand the basic distinct between supervised and unsupervised. I've seen people mix it up a lot. Supervised learning from the word supervised. It means that there's intervention of human. It means that you are doing a part for the machine. You are not just letting the machine doing its thing. You're coming in. How do you come in? You provide the input and the output. You put a label data. Okay, this is the expected output. This is what I'm expecting as the output data. Does that make sense? So it's like you're helping the machine a little bit, but the machine is going to learn from the rest. But you are doing a section by labeling your data for the machine to before you do the training. Okay. And we have 2 sections of the supervised learning. We have the classification and we have the regression. Now, classification, take for instance, you want to predict factors that affect student academic performance. And your response variable, you are looking at class of degree, first class student, second class hopper, second class lower, then third class. You are looking at this categorically. And you know that when you look at a categorical variable, they have levels. Remember when we talk about this in our week 2, we talk about categorical variable and then we talk about having levels. So when you're looking at a classification problem, take for instance the example we have a email spam detection. You want to build a machine, we want to build a machine that can classify your email spam detection. That is a classification part of supervised learning. The reason why it is supervised is because you are providing a label data. Okay. Another part is the regression. Let's say you're looking at a continuous response variable. Take, for instance, the example we talked about the class of degree. Now you are looking at student final CGPA. That's cumulative grade point average, right? If you're looking at that, that is going to be in points. It's going to be in in a continuous number, let's say 4.5, 5.0, 3.5, those are the possible values that we can have. So those are continuous, and that's also a regression problem. Another example is house price prediction. You want to know the housing price and you want to predict over time, okay? So this is another special case of supervised learning for the regression part. All right, so now let's go into the unsupervised learning. What do we mean by unsupervised? It means that you let the machine, we have no intervention. You don't come in and then you put in, it's on label. You let the machine learn directly from the data. You let it face the reality. You want to see how well the machine can properly understand the data on its own without your influence. So let's say when the machine starts training, you start noticing some form of sections, some form of segments in the data, and then you start clustering it that I think this should be in this category. This certain kind of student belongs to first class because the machine learns on its own. And then you look at the machine looks at another category and say, oh, this category of student, because of the nature of what I'm seeing, they belong to maybe second class, upper. So that is letting the machine learn on its own without your influence. You didn't label the data, you let the machine learn directly. And we can cut, like I said, when the machine sees a specific segmentation in that data, it started clustering it. Okay. Another thing we can do is dimensionality reduction. Okay, so we have the principal component analysis. We have different type of dimensionality reduction. We're going to be diving into that in details. Especially one of the main advantage of dimensionality reduction from the word dimension reduction means you are reducing the dimension of your data to a smaller form to make it easy and to make it more interpretable. Okay, so one of the most common parts where we use dimensionality reduction is when we are dealing with high dimensional data. Okay, so when you say high dimensional data, it means that your features is more than your sample size. And in that case, there's going to be a lot of noise. There's going to be a lot of things that you don't want included because of the high dimensionality. So we always try to reduce the dimension of that data to make it easy and to make it interpretable when we do our analysis. In this, we are going to dive into this in more detail. But yes, this is just to introduce you to what we mean by unsupervised. Let the machine do a thing. Let it figure it out. Supervise. I need to help you a little bit. I'm going to section and label this for you so that you can just do your training and then you optimize the model, right? So the third one is the reinforcement learning. The simplest way I would explain this is like a child learning process. Take for instance, a child touches maybe like hot water or something that's dangerous. Maybe nobody was there, and then the child mistakenly touched like an hot water. Reflex, you're going to run back. Even if it's an adult, you mistakenly touch something hot, you instantly move and run back from that thing. And then you don't go there again because it's like a try and error. The moment you try it and you realize that this thing is hurtful, I'm not going to do it again, then you learn. And then when you do it again, and then you realize that, oh, I don't want to do this again. And then from there, you don't do it again. So it's called a try and error process. That's what reinforcement learning does. It's an agent. It's an agent, a machine learning agent that learns by try and error method. And the way it works, there's a reward and there's a penalty. So it's like when you do well, it's just like you're telling your child that if you do well in school today, I'm going to reward you for this. Okay, so the same way the machine, the agent that is learning, there's going to be a reward and also there will be a penalty when you fail. So that's what a reinforcement learning is. Okay, so we're going to be moving on to the next section, which is distinguish. In some of these terms, I've seen a lot of people mix it up and then they try to make a statement, and then for people, if you're learned and you understand better, you will know that, oh, I know she's trying to say something, but it's not making sense. And that's why we have thought about bringing this section so that when you talk like an expert in the space. You don't mix it up. So the first thing that we're going to talk about is artificial intelligence. Artificial intelligence is like the big field, is the broad, is the biggest one. Okay. And inside that, what is the meaning of AI? AI means that we want to create a machine that can simulate human intelligence. We said artificial, something we are creating, intelligence to be an expert. But how do they become an expert? They use the human intelligence method. Okay? We're creating a field of machines that can simulate human intelligence. Now, a section of that is where we have the machine learning. So you can say that machine learning is a subset of artificial intelligence because it's a part of it. So when you have the machine learning, what does machine learning does is a subset of AI that learns from data. How do we train a machine? I told you earlier that the quality of your performance, the performance of a machine learning model is depending on the quality of your data. So the machine learning is a section of AI that learns from data. All right. So the deep learning is not the specialized version of machine learning. Okay. And what it does is it uses the neural network. We have a whole section dedicated for deep learning, which is going to be in week 4. So that's something we're going to be talking about in details. But for the purpose of this, we're just trying to help you understand the differences in some of these terms. And when you are talking, you talk like it. All right. So another thing is the data science itself. Data science is another field, okay? Because why is data science another field? Is because it uses some concepts. It uses the statistics, it uses the math, it uses the computer science to extract insights from data. You do visualization. But one key note with data sciences is connected to machine learning. You can see a part of that with machine learning is connected to machine learning. And if data science is connected to machine learning, what does that mean? That means it's connected to AI itself. Because remember that machine learning is a section of AI. So when you want to talk, maybe I want to talk about my research, say, oh, what are you working on? Oh, I'm currently working on a project that utilizes the artificial intelligence specifically for machine learning, where we'll be using so model. Can you see that that makes sense? You're not just saying, oh, what is your area of my area of concentration is in AI. AI, what do you mean? You have to narrow it down. You have to be more specific that, oh, I'm focusing on the machine learning where we are using this so model. Or let's say you say, oh, I am more specialized. Oh, I'm working on my area of focus is in artificial intelligence, though we're looking at machine learning, but specifically for deep learning. Because now you connected the three of them that, oh, I do know that AI is the big one. I said the machine learning is a section, but deep learning is a special version of machine learning. Does that make sense? So that is the purpose of today's class, to help you understand the difference between those terms and to introduce you to machine learning itself, to tell you the different types of machine learning. And for the purpose of this class, we said we are restricting it to the supervised, the unsupervised, and the reinforcement learning. Okay. And now that we have been able to differentiate that, we are going to be diving into the supervised learning, and we look at different models that we have under each category and how we can implement this both in R and in Python. Maybe Python. Yeah, let's see how it goes. All right, guys, see you in the next video. Do have a great day. Bye bye.